In this episode of KubeFM, I got a chance to speak to Brian Stack, who's a software engineer at Render, about what happens when Kubernetes scaling hits a dimension most teams never think about: namespaces. At render scale, hundreds of thousands per cluster, DaemonSets like Calico and Vector were list watching all namespaces on every node, multiplying memory usage, exhausting node resources, and putting sustained pressure on API server during rollouts. We get into how that led to cascading risks like noisy restarts and control plane instability, how they profiled and traced the issue down to specific components, and how a combination of upstream changes and config fixes ultimately freed over 7 terabytes of memory across their clusters. This episode of KubeFM is sponsored by LearnCube. Since 2017, LearnCube has helped engineers from all over the world level up their Kubernetes skills through courses. Courses are instructor-led and are 60% practical and 40% theoretical. Students have access to course materials for the rest of their lives, and courses are given to groups, individuals, in person, as well as online. For more information about how you can level up your Kubernetes skills, go to learncube.com. Now, let's get into the episode with Brian.
You're tuned in to KubeFM.
Brian, welcome to KubeFM. What 3 emerging Kubernetes tools are you keeping an eye on?
Thanks. Yeah. I think the one I'm most excited about personally, and the one that we keep, it's kind of occasionally useful in the toolbox, but it isn't something we get to reach for all the time yet, is Inspector Gadget. It's just been, when a lot of the time, if you have a debugging thing that you can kind of do on one node, but you have to do it on many, Inspector Gadget is just like an amazing chance to kind of do that sort of thing. And even if you're only working on one node, just having some of the tools it has ready for you in the toolbox with its eBPF is great. So that, there's a similar project from Microsoft called Retina, which is, I think, a little bit more networking focused, and we try to use that as well. And then it's, I suppose, not really a tool necessarily, but it seems like directly supporting NF tables is becoming sort of mainstreamed into becoming default supported in Kubernetes itself and a lot of the surrounding tools like CNIs. And that, for us in particular, I think is like pretty game changing. We're really excited about NF tables, writing and reading directly from NF tables rather than going through the IP tables stuff.
Very good. And for people who don't know you, Brian, can you tell us about what you do and where you work?
Yeah, I am a software engineer at a company called Render, and I spend most of my time focusing on our networking, which is everything from sort of, I should explain Render very briefly. We consider ourselves like a modern cloud. And so basically we host code that you write, and we expose you to the web and a lot of things like that. We support workflows and all this kind of stuff. But from a networking perspective, what that means I spend my days doing is everything from supporting sort of like proxying requests coming from the internet to users' pods is ultimately what they're running as, or the other direction where requests coming out of their pods going to the internet, and then all of the full mesh of pods talking to each other, basically.
And how did you get into cloud native?
Yeah, so it's funny. I think my first job in this world was at Yelp, probably, I guess, 15 years ago or something, terrifyingly long ago. And when I joined, what we were doing was we were picking up code and services that were running on bare metal, as we call them nowadays, and moving them to AWS. And so my kind of like first job doing kind of like systems and infra and operations was kind of like what ultimately amounted to replicating a bare metal setup in AWS, and then learning all the lessons that we all learned at that time along the way. And I've spent the last kind of 15 years sort of learning how to be cloud native, I suppose. Yeah.
And before that, what were you like? What kind of work were you doing?
I mean, that was my first job out of college, really. So that was, but mostly I was on the infrastructure team there. So that was just like everything from somebody was like working on puppeting up instances, and then we worked closely with the team who would literally go into the cage and put hard drives in and out and that kind of stuff. And I've spent most of my career on infrastructure there, all the way through, working on sort of like, I guess you could call them like custom CI systems, basically. At Yelp, I worked a lot on our, it was a system that like Chrome used it. It's not super common for people to have interacted with it, but a lot of projects used it, called BuildBot, is how we did CI at Yelp. And then I moved over to Mozilla to work with the BuildBot maintainer, who now works at Render as well, actually, to replace it with another sort of custom CI system called Task Cluster, which is open source and people can use it, but mostly is used by Mozilla. And then now I sort of do, Render is not really CI, but, developer infrastructure as a company. So that's how I ended up here.
Okay. And, the Kubernetes cloud native ecosystem, it moves very, very quickly. How do you stay up to date? What resources work best for you? Blogs, podcasts, videos, books?
Yeah. I mean, I'm kind of reading the same websites as everybody else, probably for the most part, the Orange one and other things like that. And, because Render is such a Kubernetes focused company, and I have a lot of peers who I really respect here. I kind of just rely on, there's a channel called Library where, and a couple others like that, where people are just posting things like that. So I have people who do that for me, in a sense. So yeah, I'm all over the place.
Good. And if you had to go back in time and share one career tip with your younger self, what would it be?
I think it's sort of, I hope this continues to be true, but like Linux is always going to be there. Like when you are back in the day, you have like your physical data center, it's Linux. You move to AWS, it's Linux. Now it's Kubernetes on AWS or bare metal or Google. It's still Linux under the hood. So like getting good at, and I think you have one of your previous episodes I was looking at, I loved the title, was something like Kubernetes is just Linux. So
Oh
like,
yeah, Eric Jalal. Yeah, that got a lot of traction on Reddit in particular.
yeah. And like, I buy that, it, in a lot of ways, Kubernetes is almost like a state of mind. And what it's doing is kind of configuring Linux at the end of the day. And so getting good at Linux is like a good idea.
Now, as part of our monthly content discovery, we found an article that you wrote titled "How We Found 7 Terabytes of Memory Just Sitting Around." Right. So we want to dig into this topic a little bit more with the following questions. Render is a modern cloud that lets developers deploy applications without worrying about infrastructure. You handle the servers, the scaling, the networking. Now, under the hood, that means running Kubernetes at significant scale to orchestrate all those customer workloads. Can you give us a sense of what Render's infrastructure looks like in terms of how many clusters, how many nodes, and how you've organized namespaces?
Yeah, totally. So to give you a sense of scale, I have the official number here. We have 4.5 million developers on the platform. So think that about that many accounts that we are separating up into namespaces. That's kind of our fundamental building block. When you are a customer, you're getting a namespace. And we do that for a bunch of different reasons, one of which is like convenience from us for operating. It's easy to switch context into a namespace and see all the resources that somebody has. But also that, for instance, like Calico net polls or Kubernetes net polls in general, apply to a namespace. So, or easily can apply to a namespace. So we have many, many, many of those. And what that means is we have double digits clusters running across. We have Google clusters. We have AWS clusters. I think we intend to have other kinds of clusters as time goes on. And they are each hundreds of nodes at a minimum kind of at this point. So that's kind of the scale that we're talking about. But yeah, each cluster has hundreds of thousands of namespaces within it. And then some of those namespaces, we have many customers, for instance, we offer a free tier, which I think is one of the reasons, like, I'm very proud of that we do that. It is like a significant amount of effort on our part. And so, many of these namespaces might have a pod or two. But then we have larger customers who have, hundreds, thousands of pods and that kind of stuff. And then all the associated services and deployments and that kind of thing. And then obviously for the way we are operating this is primarily through writing operators and DaemonSets. So, we have many DaemonSets that are sort of like popular open source tools that we're running on every node. We have some that we've written custom, and then operators, many operators to operate it all.
Hundreds of thousands of namespaces is quite unusual. Most teams talk about scaling in terms of pods or nodes, but you've described the namespace dimension as your hypercube of bad vibes. Now, that's a t-shirt waiting to happen. What makes a large number of namespaces particularly problematic, and why does that dimension hurt more than others?
Yeah, I mean, I think there's two kind of answers. One is technical, and one is more social almost. And the social one is basically very few places have this many namespaces. So it's one of the dimensions of the Kubernetes. I think the technical term for that image is like the scaling envelope or something like that. It's a dimension on the scaling envelope that very few people optimize for, because most people are running Kubernetes clusters with 10, 100, namespaces or something like that. And so it's sort of we get to pick a lot of low-hanging fruit, basically, optimization-wise, because most people, don't optimize it. So that's one angle. I think the sort of technical side of it is most things like many DaemonSets, for instance, might list watch all pods on a node or something like that, like pretty common pattern. But it's possible to filter your request to pods on that node. Namespaces, you're not really, as far as I know, now that I'm thinking about it, I should make sure of this. But yeah, like namespaces don't really have a pod or a node to filter on. So when you list watch namespaces, you list watch all of the namespaces. And so that is, it's like fine for, say, an operator where you have one or two instances, but I think we'll talk about it more coming up soon, but that's really a dangerous thing when you have hundreds, thousands of nodes that are all doing that against one API server.
And DaemonSets run a pod on every node in the cluster. So if you have hundreds of nodes and each DaemonSet pod is independently watching namespaces, the memory cost isn't just per pod, it's per pod times every node. How does this multiplication show up in your clusters?
Yeah, so from the title of the article, one way it shows up is when you start taking off large and larger chunks of memory from every node in your cluster, it adds up quickly when you multiply it. And another way is API server has to handle these requests. And so if you have, and this is a heavy duty request generally. So if you have hundreds of nodes, each of which is list watching hundreds of thousands of namespaces, say that you have an event where Vector, for instance, has to be rolled out. That could be a very stressful time for API server and etcd backing it and everything. So that's kind of the way that like multiplication works. You can basically DOS yourself by say restarting Vector or something like that.
Calico handles networking and watches network policies, which you define per namespace. You work directly with the Calico maintainers to optimize how it handles the scale. What did that collaboration look like?
Yeah, we love the Calico maintainers. Arguably one of my favorite open source projects. So we have to run Calico on every node, obviously. We, Render is sort of in an interesting position where we're growing quickly. And so there are many, and this came up in the like comments on the article and things like that. It was really interesting to see both sides of the coin, where some people would say, wow, you let this problem get to this point, that's nearly malpractice. And other people would say, well, 7 terabytes of memory is like, 3 servers that we run or something like that. So, but basically what can happen is if you're not looking at it, if you're not spending your day every day looking at the amount of memory that your daemon set is using. It can creep up over time. And so Calico memory creeped up over time, and it got to the point where we decided that this was sort of not sustainable for us. It's less of a reliability concern for the most part for us, and more of a cost concern, right? Because if every bit of node that we use is less node that we can sell to people. And so we noticed that this was a problem. We have a pretty extensive setup of basically all of the LGTM stack, so we have Pyroscope and Tempo and all these bits of stuff that Grafana has put out there. And so when we noted and Go, which we'll talk about Rust in a little bit, but Go has fantastic built-in support for profiling it, basically. So the easiest first thing to do is just point Pyroscope at Calico and see what's wrong. And so it was very obvious where all this memory was being allocated. But at that point, our ability to, Calico is a huge, complicated project. And so we kind of got to the point where we said, okay, we've diagnosed approximately what the problem is. I don't think we can fix this ourselves. They have a fantastic Slack. The maintainers are very active there. And we basically showed up and said, hey, we have these profiles, explain the problem that I just explained to you, and, what's going on? And they almost immediately were like, oh, this is so interesting, and took the profiles and went back and were able to kind of figure out where the issue was, which specifically it was or it wasn't even an issue in particular. It was that they figured out a way to optimize this, which is sort of compressing all of these network policies in memory when they're unused, because they have every network policy, but only maybe 110 at most are in use on a node at a time. So they can compress the ones that are remaining. And so then it ended up being a little bit of a back and forth of okay, hey, we've made this patch. Can you build a version and deploy it in your staging cluster and test and then kind of cycle back and forth with passing profiles back and forth and that sort of stuff. But really, 99% of the credit is to the Calico maintainers. We just had a big cluster and were able to profile well.
And to validate the Calico changes, you built a staging environment with hundreds of thousands of namespaces. And that's not a typical test setup. What did you learn from running at that scale? And what else did you discover?
Yeah, I mean, it in terms of scaling up to 100,000 namespaces, pretty easy in a way. You just have a little for loop and let kubectl get to work. But obviously our production clusters have more namespaces than that. So we didn't have any Kubernetes worries necessarily, but in the kind of quietness of a staging cluster, we were kind of and looking closely at everything. We noticed something funny, which was, hey, Vector's memory is scaling exactly proportionally to the number of namespaces we've created, which upon reflection makes sense, but at the time we found very surprising. And so we thought, okay, we're getting all these wins from in terms of memory from these Calico improvements. Can we take another little bit of time, tack it onto the end of this project, and see what we can find with Vector as well?
And Vector handles log collection, not networking. What was it watching that cause the same scaling problem?
Yeah, so obviously Vector didn't have anything to do with the net polls themselves. So it was literally just list watching namespaces. And the reason it has namespaces is you can enrich your log lines with, say, labels from a namespace. So if your namespace has a label that is this is user 123, you can add that as a field in your log lines, and which is sort of one of the purposes of Vector when you're using the Kubernetes log source. And as we said earlier, for most companies, most deployments of Kubernetes, that probably doesn't even move the needle at all, right? Because you have maybe 10 namespaces and you just pull them in and it allows you to enrich with that valuable data.
So you have this feature that's useful for most users, enriching logs with namespace metadata, but at your scale, it's expensive. When you looked at your actual vector config, what were you using those namespace labels for?
Yeah, it turned out that we were pretty lucky in that, we have approximately two kinds of namespaces. One is users, our customers, and one is our own code. Um, and unsurprisingly, those namespaces have a label that says user namespace or not. And so that was the only thing we were using the namespace labels for. All of the other enrichment was on the pod itself, all the pod labels. And so this kind of was very encouraging to see, because we thought to ourselves and validated this by talking to the vector maintainers, who also have been fantastic and very supportive, that maybe you just don't need that.
That's a pretty neat workaround. Replace a label lookup with a string prefix check on the namespace name, but Vector didn't have a way to disable namespace watching entirely. You ended up contributing that feature upstream. What happened when you tested the change?
Yeah. So I guess I forgot to mention how we fixed that. So it was easy to remove the namespace label because our user namespaces also kind of follow a naming convention that makes sense and is static. So we can just use the name of the namespace, which you don't need the namespace for. So we removed it, but obviously Vector wasn't sort of like smart enough to know, oh, I don't need namespaces anymore. It doesn't sort of like pre-compile everything and no more list watching namespaces. And so we looked at the code, and it's sort of more straightforward than you think. One of the biggest changes, if you are sort of a Kubernetes shop and you spend, I don't know, 99% of your time writing Go, is it's in Rust. But I love Rust. It's a beautiful language and is actually more readable in a lot of ways. So it was fairly easy to find like where this was happening, and it seemed likely that we were going to be able to just add a config flag to turn off namespace list watching. And so that was basically what we did. But it's a system that we obviously run at scale, but don't have. I'd say we've like some parts of our system that we have, I would say, very deep knowledge of, and others where we sort of are like, hey, this tool fits this shape, and let's deploy it. Hey, it works. Which that's more of our vector story up to this point. And so we were sort of nervous about making this change. What if it is relied on somewhere, or what if somebody later comes along and re-adds a namespace label enrichment? What will happen? And so that's why we wanted to talk to the maintainers about this, and rather than kind of like just YOLOing it out into prod. And so they were very helpful, and we're like, yeah, this definitely makes sense to do. Making the change itself, like I said, at a surface level was fairly easy. It was probably like a day of like poking around and getting a Rust build set up and all that kind of stuff. But then there was sort of it turns out, something that was relying on namespace labels that was in a different, I forget the Rust term, but in a different file, and that had kind of missed our sort of like naive approach. And so when we deployed this to our staging environment, we got significantly reduced memory, but no logs were being emitted, which obviously sort of defeats the point. And this is where the LLMs came in handy a lot. It's sort of it's a really great lever when you're working in a code base that isn't familiar to you, that you don't spend your whole day kind of thinking about. And it was, you can see it in the blog post. The prompt was not complicated. It was just, hey, I'm not getting logs anymore. What's happening? And it was able to fix that pretty easily.
A 50% reduction is a massive win, and you could have stopped there. But your teammate Hieu looked at the numbers and something didn't add up. Vector was still using 1 gigabyte per pod, even without namespace data. What made him push further?
Yeah, I mean, Hieu is the beating heart of the infrastructure team here, I would say. So yeah, I mean, it was like it just didn't make any sense. Where was this extra memory coming from? And yeah, it sent me off on a really deep adventure that turned out to be rather surface level solution at the end. But yeah, like I was mentioning earlier, we're kind of one of the ways Go spoils you is its excellent profiling support. And in like a server environment and everything. And obviously Rust has a lot of support for profiling and this sort of thing. But it is harder to profile in sort of a distributed environment. Like there is no, profile endpoint that it spins up as an HTTP server that Periscope can just point at quite in the same way. And so, we have people here who did research that involved Valgrind or I've actually never known how to pronounce it, but Valgrind is what I say. And that sort of stuff. And we're kind of gearing up for a really heavy duty, like let's profile some Rust work before I was doing one of these deploys to support this and noticed that, we have 2 places that we've been list watching namespaces this whole time. And if you have 2 Kubernetes log sources and each one list watches pods and namespaces, they both independently do this. I don't know. Maybe Vector could be changed to sort of like share a common cache or something. Who knows? But in our case, it was much easier to just disable it in both places, and that brought the memory back down to negligible. So that was great.
You spent hours profiling, and
Yeah.
you even asked the team if anyone had experience with Valgrind. I hope I'm saying it correctly as well. That's what I've always said, not Valgrind. But yeah, so had you asked anyone in the team if they had experience with Valgrind, which is a low-level memory debugging tool, which is quite deep in the weeds. Eventually, you found the answer. What were you missing?
We were just missing that we were list watching twice. Vector does not, as far as we can tell, sort of like if you do 2 Kubernetes sources, that's 2 separate controller patterns, basically, that it's list watching with. So I guess it's not a controller, but it's 2 separate list watches. So it might not surprise you, but our vector config is rather lengthy, and different teams have different perspectives, views into it. So I was kind of looking at the part that I was most familiar with, but another part was another separate list watch of all of this stuff. And so that's how we were able to find that we were just list watching twice, and that both places needed this new flag that we'd created to be set.
From nearly 4 gigabytes per pod down to tens of megabytes. Across all your clusters, 7 terabytes freed. Beyond the raw memory savings, what changed operationally?
Yeah, this is the most important part, actually, in many ways, because in a sense, using memory on a node is just a cost thing for us. And, we spend different amounts of effort improving our efficiency depending on all these different things that are going on. So, we're perfectly happy in a sense to trade some cost efficiency for reliability and performance and features. But the part I mentioned earlier where restarting Vector, for instance, really pummels API server, that had been the cause of multiple incidents for us in the past, right? Where you kind of take this component that you think, it's pretty safe, it's Vector, it's just list watching, or it's just forwarding logs along. But it turns out that if every node in your cluster is list watching namespaces, and you have a large enough cluster and enough namespaces, if, for instance, Vector starts ooming and crashing across much of the cluster, you can and will take down API server. We over time, and that's kind of the unexpected way to take down API server. And then the expected way that we also had run into was literally doing a rollout of Vector. So we had added a bunch of machinery over time to do a very measured, very slow rollout of Vector in order to not sort of like impact our API server load at all. But what that means is, say you have an issue with Vector and you need to fix it right now, it would take hours potentially to like roll out a new Vector. So now with this change in place, we can kind of roll Vector like we roll any other DaemonSet or any other process. It's very lightweight, it's very quick, and we've had situations since then where that has really come in handy, where we needed to quickly change something about how we were forwarding logs in the cluster, and it was like, done half an hour maybe or something like that, instead of like, this is going to be a day.
So there were at least 3 moments where you could have declared victory. After the workaround, after the 50% drop, after the PR merged. Hieu's question pushed you past the second one. What kept you going instead of shipping the win?
Yeah, I mean, I think it's Render is pretty good at this, I think. I've really great teammates, actually. I can't say enough nice things about the people I work with. And we are, as a company, intent on moving quickly, and there's a lot of times where you should kind of take the win and move on. But because there is a huge amount of surface area for what is a relatively moderately sized team, we do encourage people, I think, to dig a little deeper when they get a chance to. And we find that it nearly always pays dividends down the road. A lot of the techniques we used in this blog post and have been followed up with subsequent work in other places. So taking the extra time to kind of truly wrap your head around the problem helps a lot. And it shows up in ways for us with like, I think getting a project to 100% takes a little longer, but over time actually makes you move much faster. Like we can at this point sort of like ignore Vector for the most part. Whereas I think if we'd kind of fixed it to the 80%, we'd still be dealing with issues all the time. So that's kind of the mindset.
You ended your article with a question: do you really need those namespace labels? For teams out there that are running large multi-tenant clusters, what should they be looking at in their own DaemonSets?
Yeah. I mean, I'd say like be paying attention to your DaemonSets is the first bit of it. It can be a little bit annoying to keep track of them all, even with all of the metrics and everything that you can emit and support these days. So yeah, watch for memory increase. Obviously, watch for CPU increase, and then almost more importantly, be watching API server. API server certainly it emits a lot of fine-grained metrics, or at least we have fine-grained metrics. I think it's just raw API server that we're looking at. And then also, what do they call them? Audit logs that it emits is very useful. And so watching API server to see like this resource is being requested a lot, and it's equating to like an increase in CPU or memory or something. That's what you really want to keep your eye on, because when that starts to get squirrely, that's a bad day. That's a bad day.
Brian, what's next for you?
Yeah. So like I said earlier, I spend most of my time working on networking. And so we have a project that's I'm working on right now that is going to be able to deliver dedicated static IPs to customers who want that sort of thing. So that's very useful for people who like have to talk to a database and want to like lock it down to just IPs that they own, basically. And that will simultaneously be sort of like, helping reduce our networking costs, which will help us offer networking bandwidth, which is the aspect that we charge on for less, hopefully, or something along those lines.
Okay. And if people want to get in touch with you, what's the best way to do that?
I have an email at brian@render.com. I have a Blue Sky that is mostly personal. I don't talk about work too much there, but if you do want to talk to me there, I think I'm just bstack.
Very good. All right. Well, folks can find you there. Brian, thanks so much for sharing your time and your knowledge, your experience with us today. I'm sure a lot of people are going to benefit from this and look forward to hearing more about your work in the future. Take care.
Thank you. It was great.
You're tuned in to KubeFM.